Hello students, this is me Saurav Paroi. I am making this recording for the students of class 8 for the subject of mathematics. Students, in this particular video we are going to learn about the probability, and in this particular video about the exercise solution of this particular chapter. Okay. Before I begin, you have a guide to watching this video. For better understanding, you have to set the quality to HD, that is 720 pixels. Okay. And if your data connection is a little bit slow, then at least 480 pixels, and preferably watch the video in full screen. So this video has been divided into two parts for the convenience of your understanding. In the first part, that is in this part, we'll be discussing questions from 1 to 5. In the next part, we'll be discussing from question number 6 to question number 10. Okay. Without any further ado, let's start the class. As you can see, this is the question. This is a word-based question. Before going to solution part of this question, you have to understand the meaning. Let's read the question as it is. Find the probability that when a die is thrown, the number shown is, first one, an even number, second one, a prime number, and third one, a number less than 5. So there are 3 different questions that you have to answer. So tell me students, I hope every one of you have seen a Ludo die. So on the die, how many numbers are there? There are a total of 6 numbers from 1 to 6. How many even numbers are there? Or what are the even numbers from 1 to 6? These are 2, 4 and 6. Again, what are the prime numbers from 1 to 6? It is 2, 3 and 5. Okay, then a number less than 5. What are the numbers less than 5? These are 1, 2, then 3 and then 4. Okay students, so these are the numbers. So there are a total of 3 even numbers, there's a total of 3 prime numbers and 4 numbers that are less than 5. After you have understood it, let's go and move on to the solution part. This is a usual portion. You have to assume it as it is A be the event of getting an even number, as the name of the event is not given. So what are the even numbers? You just list it here, as we have just already discussed about it. These are 2, 4 and 6. How many numbers are there? 1, 2, 3. So there are 3 even numbers, and these 3 outcomes are favorable to event A, because if any of these 3 numbers come up after rolling the die, then we are getting an even number, which is our condition to be fulfilled. Okay. So the total number of, again on the die, it is not going to change, it is going to be 6, and this is the total number of possible outcomes, because any of these 6 numbers can come up after rolling the die. So therefore you can calculate the probability using this formula, that is number of outcomes favorable to event A divided by total number of possible outcomes. Replace the values, 3 divided by 6, and this will give you how much? 1 by 2 after cancelling out the common factor. Hope this one is clear. Based on the same principles, we have the second solution, that is for a prime number. The prime numbers on a die are 2, 3 and 5. So the number of prime numbers are going to be 3, and these are the numbers or outcomes favorable to event B. Total numbers on the die, it is going to be 6, and this is the total number of possible outcomes. So the probability of event B is going to be number of outcomes favorable to event B divided by total number of possible outcomes. Again, we replace the values in the formula, and after cancelling out the common factor, you get 1 by 2. Third one, we have assumed this event to be C, that is of getting a, and numbers less than 5 on the die are 1, 3 and 4. So 1, 2, 3 and 4. 1, 2, 3 and 4. So number of numbers less than 5 are going to be 4, and this is the number of outcomes favorable to event C. Total of numbers on the, so this is the total number of possible outcomes, and thereby probability very easily. just reduce in the formula. The formula is same except for this one. The event assumed here. You have to write the same event here. Cancel out the common factor and here you go is your answer. Next. Observe here. Find the probability that a card drawn from a pack of cards is a red card, an ace, a black king, and not a king. Okay, there are actually 4 questions that you have to answer. Now, in a pack of cards, before we go on to solving it, let me briefly discuss about a pack of cards. In a pack of cards, there are a total of 52 cards. How many cards, students? 52 cards. These 52 cards, they are divided into 2 parts. 26 cards and 26 cards. These 26 cards are black. And here we have other 26 cards are red. The black 26 cards, these are again divided into 2 parts. And the red, similarly, they are also divided into 2 parts. We have in the red category, we have diamond and hearts. Okay. And in the black category, we have clubs and spades. Okay, students. So in each of these categories, we have 13 cards. 13 and 13 cards for each one of these categories. That is this one. Okay. So in each of these, that is for diamond, there is an ace. Okay. Ace. For clubs, there is an ace, and for spade there is an ace. Plus 2, 3, 4, 5, 6, 7, 8, 9 and 10. So after ace, there are from 2 to 10 number cards. After number cards, that is after 10, you have jack, which is represented with the letter J. Then you have queen, which is represented by Q, and the last one is king, which is represented by the letter K. Okay, students. And these cards are common. These cards are common for each of these 4 categories. Okay. So if I ask you how many total aces are there in these 52 cards, so one is for diamond, one is for hearts, one is for clubs, and one is for spades. So there are a total of 4 aces in the pack of cards. Again, if I talk about jack, how many jacks are there? 1 jack for diamond, 1 jack for hearts, 1 for clubs, and 1 for spades. That is a total of 4 jacks are there. What about queen? Similarly, in the same way, you have 1 queen for diamond, then 1 queen for hearts, then 1 queen for clubs, and then 1 queen for spade. The same applies to king also. That is, there is a king for, there is a king of diamonds, then there is a king of hearts, again there is a king of clubs, there is a king of spades. Good. Now there is a concept of face cards. Jack, queen and king. On these cards, a face is printed. We'll find a face printed on these cards, and therefore these cards are also known as face cards. There are a total of 12 face cards in a pack of 52 cards. That is 3 from the diamonds, 3 from the hearts, 3 from the clubs, and 3 from the spades. A total of 12 face cards are there. If we talk about a black king, so these club and spades are black. Okay, so one black king from clubs and one black king from spades. Got it, students? So there are a total of 2 black kings in a pack of 52 cards. Let me erase this, and after that we'll move on to the solution part. Okay, let me quickly erase it. Okay, this is enough. Pen. So the first one is a red card. There are a total of 26 red cards, as I have already told you here. So here it is. Number of these are this is the outcome that is favorable to event A. Total number of cards, as I have already told you, it is 52. Replace it in the formula. Just place it in the formula, cancel out the common factor, and this will give you 1/2 as your answer. Now the next one, an ace. As I have already told you, there are 4 aces, 1 for each category. Okay, so this is the number of outcomes favorable to this event B, and there's a total of 52 cards. Replace the values, that is number of outcomes favorable to event B divided by total number of possible outcomes, and this will give you 1/13 as your answer. Now the third question is a black king. A black king, as I have already told you, there will be 1 black king for spade and 1 black king for clubs. So a total of 2 black kings are there in the pack of 52 cards. So this is the number of outcomes favorable to this particular event. 52 is the total number of cards. Replace the values here. That is 2 divided by 52. Cancel out the common factor, and here you go. It is your answer, 1/26. Last one, not a king. You have to assume let D be the event. This is the same thing. The same thing gets repeated over and over. Okay. Now, in case of not a king, how many kings are there? 1 king for each category, that is 4. Okay. Total number of cards is 52. Okay. So, if we take out these 4 cards from a pack of 52 cards, then other cards are not going to be king, and our condition will get fulfilled. Okay. What I am saying is that there are a total of 52 cards, and out of 52 cards, 4 cards are king. If we take out these 4 cards from the 52 cards, okay, then the remaining 48 cards are surely not king. Yes, I hope this is clear. So this is the number of outcomes favorable to event D, that is of getting not a king, of getting a card which is not a king. And in this case, the total number of cards is going to be how much? 52. Then after you replace the values, cancel out the common factor, and here you go. This is your answer, 12/13. Done, students? Now, as usual, I'll explain this question first, and then we'll move on to the solution part. A wheel with 3 equal sectors. So let's draw a wheel with approximately equals 3 sectors. Okay, and these sectors are painted red, green, and blue. So let's suppose this is red, then we have a blue here, and this is green. Okay, so what happens next? What is the probability? Okay, it is spun, so there is a pointer here. Okay, spun, the verb 3 form of past participles form of spin. Spin is to rotate it. Okay, so what is the probability that the pointer will rest in the green sector? So this is there is only one green sector. Out of how many sectors? This is 3 sectors. So there is a probability of 1/3. okay, because there is only one green sector and the total number of sectors are 3. So 1 divided by 3 is going to be the probability. Don't worry if you don't understand, you will understand in the solution part. And will not rest in the green sector. So how many sectors are there that are not green? So we have blue and red. These two sectors are not green. Okay. So there is a probability that there are 2 different sectors out of 3 sectors that are not green. I hope you understood the question. Let's go on to solution first now. Use as usual our assumption for this one. Actually this is number 2, not 1. Okay. So the number of green sectors in the wheel is 1. As I have already told you, there is only one sector. So if we spin the wheel, okay, if the wheel is spun, okay, then there is only one sector. If the pointer rests here, we'll get the green sector. Okay, so there is only one such possible outcome which is favorable to this particular event. Okay, total number, as you can count here, 3. So this is the total number of possible outcomes. Replace the value here and this will give you 1 by 3 as your answer. Next, this is the event B, not resting in the green sector. Then there are 2 sectors that are not green, as I have already told you there just now. So the outcomes, there is 2 outcomes that are favorable to this event. Okay, and the total number of outcomes is again 3. So this is the total number of possible outcomes. Replace the values and this will give your answer 2 by 3. Okay, now the fourth one. In this case we have a bag. Okay students, in this what we have a bag, and this bag contains 4 marbles that are red and 8 marbles that are yellow. Okay, this is the situation. Now randomly, okay, find the probability. If we pick a marble, from the bag, we have to find the probability of picking a yellow marble and a red marble. First of all, tell me how many marbles are there. That is 4 plus 8, it is going to give you 12. A total of 12 marbles are there in the bag. Out of 12 marbles, 4 are red, okay, and 8 are yellow. So if we want to calculate the probability of picking a yellow marble, so it is going to be 8 by 12. On cancelling out the common factor, this will give you the answer. In case of picking a red marble, then how many red marbles are there? There are 4 red marbles. So this the probability is going to be 4 divided by 12. How? Here you go with the solution. Okay, let B be the event of picking a yellow marble. So the total marbles, that is yellow marbles, are 8. So this is the number of outcomes favorable to this particular event, because if any of these 8 marbles is being picked, we will get a yellow marble. This is for sure. Total number of marbles in the bag, it is 12. So this is the total number of possible outcomes, and therefore the probability is going to be the same formula here. We replace the values 8 divided by 12, cancel out the common factor, and this will give you 2 by 3 as your answer. I hope this one is clear now. Similarly, the next one. Let's see with the event of picking a red marble. There are 4 red marbles here. So these are the outcomes that are favorable to this particular event. Again, there are a total of 12 marbles and this is the total number of possible outcomes. You write the same formula replacing this event. Okay. Replace the values. This is number of outcomes favorable to event C is 4 and 12 is the total number of possible outcomes. So on cancelling out the common factor, this will give you. Okay, move on to next question. In this question, we have 1000 bolts in a box. 20 are defective. Okay, so there are 1000 bolts. Out of this, 20 are defective. So if we subtract 20 out of 1000, we will get 980. So we can say that this 980 bolts are good bolts. Yes or no, students? Okay. So if we have to calculate the probability of picking a defective bolt, then how many bolts are there? 20. defective bolts. So 20 divided by 1000 will give you the answer. Okay. And in case of a good bolt, here we have 980 good bolts out of 1000 bolts. Okay. So this will give you the answer for this Roman number 2. Here is your solution. Let's see with the event of picking a defective bolt. Number of defective bolts in the box is already, as it is given, 20, and this is the number of outcomes favorable to event C. Total number of bolts in the box is 1000, and this is the total number of possible outcomes. Now the probability of event C is going to be based on the formula. This is the number of outcomes favorable to event C divided by total number of possible outcomes. Replace the value, cancel out the common factor. This will give you 1 by 50 as your answer. Okay. Next, there is a good bolt. That we have, first of all, we have to calculate the number of good bolts. It is 980. Number of outcomes favorable to event D. So here we have a total of 1000 bolts. This is the total number of possible outcomes. The probability of event D is going to be number of outcomes favorable to event D divided by total number of possible outcomes. Now replace the value, cancel out the common factor. This will give you 49 by 50 as your answer. Okay, students. So with this, we have come to an end of this particular lecture. Thank you for watching. Hope you enjoyed it. If you have any doubts, please let me know.